Now where all you need this channel, right? Now you know how much space to give between the channels. Okay, one more question. If I have to allow standard cells, this is if I don't need to allow standard cells. Okay, now let us say if I have to allow standard cells, let us take the same situation. Let us zoom in to this. There are pins, 100 of them. There is this macro, and you left 200 microns space from your calculation, right? From your calculation, you left 200 microns space. That is, you have not taken into consideration any standard cells here. Now let us say if I want to take a standard cell into consideration, if I want to add buffers, if I don't have any buffers exceeding the length of 200 microns, then I don't need to worry about the width of the standard cells. Let us say I have a buffer which is 250 microns in width, very big buffer, let us say 64x drive strength. Width is 250 microns. Then definitely if I want to add a buffer here, 200 microns won't be sufficient. Automatically this 200 will become 250, right? That is one consideration. Second consideration is, if I want standard cells, I should have VDD and VSS, right? I should have VDD and VSS to give power to the standard cells. VDD and VSS are in metal 6 and 7. VDD and VSS are in metal 6 and 7. Since we are considering vertical routing, we will consider metal 6. So I want to put a standard cell here. Its width is not more than 200 microns. So 200 is sufficient for the cell. But for the nets, I need to check now. I have VDD and VSS, which is in metal 6. I should at least have one pair of VDD and VSS. I don't need multiple stripes. At least one VDD and one VSS should be there in the channel if there are standard cells. Now to accommodate this VDD and VSS, I should know the width of this. So width of VDD, this can be calculated by width of VDD plus width of VSS plus spacing, right? Any doubts here? This is width of VDD plus width of VSS plus spacing. If it is less than 200, then we will go with 200 only, because all my pins have to be routed. If it is greater than 200, let us say this is equals to 350 microns, then clearly 200 is not sufficient. If I am allowing standard cells, 200 won't be sufficient. I have to increase it to 350. Even if this is less than 200, even if this is less than 200, I have calculated all the vertical resources only for the pins, right? Again, I will, in metal 6 I have VDD VSS. In metal 5 I will again have VDD VSS, and in metal 4 also I will have again VDD VSS, right? So I have not calculated that for vertical routing. So I have to slightly increase this 200 microns to another 20 microns or 30 microns. So depending on if I'm allowing standard cells or not allowing standard cells, I have to put the channel spacing. Okay. So channel spacing will be number of pins into pitch of highest routable layer divided by number of layers by 2, right? For without standard cells in the channel. If there are standard cells, you have to accommodate for one pair of VDD and VSS with standard cells. If there are very big cells, then width of those cells, sorry, width of bigger cells for very big buffers, right? So whenever somebody asks you, how will you calculate width of the channel, right? How will you calculate width of the channel? Simple question. So width of the channel can be calculated by number of pins into pitch of the highest routable layer in that channel by number of layers by 2. This is when standard cells are not taken into consideration. If standard cells are taken into consideration, I have to also think about one pair of VDD and VSS, right? And if I have any always on buffers or something like that, which are very big in size, then if I want to place those cells, I have to take that width of those bigger cells into consideration, right? That should be your answer when somebody asks, how will you calculate channel spacing? Got it? Any doubt? You want to note it down? Please note it down, because in every interview you will get this question: how do you calculate channel spacing? If there are no cells,
Sir, is there any condition to have one pair of VDD and VSS in channel?
yes, it is always good to have one pair of VDD and VSS in channel, because your S route or your metal 1 routes will stop at the macro, right? They have to get some power from the top layers. You will start your S route from the beginning of the core and you will stop at the macro, because through the macro you cannot go, right? So you have to accommodate for some power availability from the top layers to your metal 1. Only then metal 1 can power your standard cells.
Okay, sir.
Yeah. If you guys have noted, we will move on. Yes, no.
Yes.
Okay. Now every macro, if you consider, you know that macro is a predefined logic block, right? It will have some layers consumed inside itself, right? And therefore, for every macro, some layers will be blocked, which means there will already be metal 2 inside the macro. So you cannot draw metal 2 over the macro. Metal 2 cannot cross over the macro because it will get shorted with the metal 2 inside the macro, right? So every macro will block some layers. You must have seen in your design, macros will have routing blockages over them. Have you seen or not? Yes or no? Yes, guys, have you seen routing blockages on your macros in your respective designs? Okay, if not, there will be routing blockages. Yes, Lokesh, you have seen, is it?
I had created a routing blockage, sir.
You create a routing blockage over the macro. Fine, that is also fine. From top level suggestions, you create a routing blockage over the macros. That is because you will have routing inside the macro that will actually, where is this? Yeah, the routing inside the macro will actually interfere with the routing in your block. And that's why you have created routing blockages. Now, not all layers are blocked. Since my block has 6 layers, macro won't have 6 layers in it. Okay. Let's say till metal 3 it will be blocked. So that is why I use the word some. Let us say metal 3 it will be blocked. Now here I showed you that routes have to go like this, right? In the gap between the macro and the core. Now if you are using over metal 3, let us say I'm using metal 4, I can go over the macro also like this. Apart from whatever layers are blocked inside the macro, if I'm using higher layers, let us say horizontal I used metal 5, vertical I used metal 4, and horizontal I used metal 5. This route has nothing to do with the macro because macro only has metal 3 in it. So whatever we route in metal 4 or metal 5 has no interference with the macro. It can go over the macro, right? Now inside the channels, we will have different types of requirements. Okay, if I have a macro channel, I will have different types of requirements. Let us say if I want to avoid any standard cells in the macro region, then I will put a hard blockage. Avoid all standard cells. If I want to allow buffers and inverters, I will put a soft blockage. Now, if I'm again allowing buffers and inverters, I have to look for how do I give the power to them, VDD and VSS, right? Again, if I have to see if there are bigger buffers, if the size will be sufficient to fit in the channel. All these things should be taken care of while calculating channel length. So why do we need buffers and inverters? Anyone? Why do we need to insert buffers and inverters in the channels?
To meet
Right?
timing requirements.
To meet basically DRVs. Yes, timing requirements. If tran cap violate, it can lead to setup and hold violations. So to meet the DRVs, basically tran, cap, and fan out. Basically tran and cap, right? So if there is a net going like this, if there is a net going like this, to some standard cell here, we cannot have this long net, right? We need to buffer it here. I need to place a buffer here because this will have a tran violation. Since the net will have a tran violation, I need to use a buffer here. That is why I need to give a channel. Sometimes what happens is my macro will be there, other macro will be there. The macro pins will be on this side and other macro pins will be on this side. The pins are not at all facing each other. So we will think, okay, since the pins are not facing each other, I can abort these macros, right? You can abort these macros, but not in all cases. For example, here in this region, you can abort these two macros, but you won't have the space for buffering of the nets. Got it? Everyone able to understand? I don't have pins on this side. I only have pins on the right side for both the macros. So this does not have any pins. This also does not have any pins. But some net is going over the macros to this standard cell. In order to buffer that net, we should have some space here. In that cases also, we have to leave space gaps between the macros. Usually what we do is when macro pins are facing towards each other, what we do is we will calculate the spacing between the macros using this formula and then we give spacing. When macro pins are facing away from each other, we will just abort it because we don't need spacing. This is fine when you only have two macros in your design. This is fine because any route can go like this or go like this. But if you have more macros, like your design is completely filled with macros, right? There is some register here, some cell here talking to this macro, last macro. This net will be in the core area from here to here, but from this point, it will only be traveling over the macros to here. And if this net length is very long, let us say 500 or 700 microns, definitely there will be a tran violation. So we have to anticipate these scenarios and leave gaps in between the macros. We should leave gaps for buffering in between these macro channels. Understood? Understood or any doubts? So this is about macro channels and why we need channels, how much channel spacing we need, right? All these things we have covered.